All right. Hello again, everyone. My name is Dima. I'm working in JFrog for the last 5 years. All this time I was working as a Go developer, and actually only last couple of weeks ago I encountered this package first time in my professional career, and it was a discovery, so I wanted to share it with everyone because I find it useful, and I hope that you will find it useful as well. Just some random tech about me. I like playing piano. So that's about me. Now let's go into the problem description. So I think you all are familiar with the weight group. Weight group comes with Go out of the box, and it is a means of synchronizing. Spawning some workers and then waiting for all those workers to continue. So this is a very common pattern. We just define wait group. We spawn some workers. For each worker that we spawn, we need to add, to increment the work group. Then we spawn the Go routine, and after the Go routine finishes, we mark it as complete by the call done. And then we issue a call in the end that is called wait. And this wait ensures that all the Go routines are finished. When this call returns, the wait call returns, we know that all our Go routines are finished. This is a super common pattern. Okay, but what is missing here and is super common need? What happens if we have a function that returns an error and we want to know and maybe fail the whole operation if error is returned from one of those workers? So now we need regularly, we would need to introduce some kind of channel, pass it to the worker, wait on this channel. And we have actually something that can wrap this for us in a pretty nice way. It doesn't come out of the box with GoLang. You need to install it as a module, but it is official from Google, called Errgroup. So this code is kind of symmetrical to the code that we saw earlier. Instead of the sync wait group, we define an error group. And then when we spawn the Go routine, instead of directly calling the Go command with Go func, we can call instead on the group the method Go and pass it a function that can return an error. So this code is, and then in the end we call the wait method, and the wait method waits until all the Go routines are finished, and it will return an error. If some of the Go routines return an error, it is enough that one of the those workers returns an error, that our error group will return an error. Actually, it will return the first one. The first error that we received, this will be the one that is returned, and all the others will just be not presented, ignored. So this is how it behaves. But then we want probably to add something else. We want to say, all right, but maybe if I had error in one of the workers, I want to stop all the processing altogether, right? I already know that the operation has failed. It is enough that one of the workers failed, that all the operation, failing the whole operation, and I want to signal to all of them to stop and to continue stop the processing, because there is no need to continue processing anymore. The operation has failed. So how do we approach that? So for that, we have another functionality of the Errgroup with example that I'm going to present now. So Errgroup is actually very, very simple and small interface. It has two methods that we already are familiar with, which is the Go method and the wait method, and one that I didn't introduce yet, and I'm going to introduce now, that is with initialization with context. Okay, So what we did previously, we just initialized the pointer to the group. But another way would be to call the with context method that would return the group. And then we could use this context to see if it was canceled or not. I'm going to demonstrate shortly. So let's take a very, very common example, a pipeline. Okay, a pipeline consists of some sender, task generator, one routine that generates the tasks and sends them to workers. We have a group of workers that are processing the tasks that the generator sends to them. Task generator generates tasks, and in the end, after it completed generating all available tasks, it should signal that it finished generating the tasks so that the workers know that no need to wait, they can exit. In case some error happened, either in the generator or in any of the workers, we would like everything to stop. The generator to stop, all the workers to stop, and to exit. And the main process should wait for all the routines to complete. And if some error happened, it will return an error. If no error returned, we will have a success. All the processing is completed. So this can be implemented in regular Go, but the Errgroup provides a very elegant way to do it with minimal code. So how would we approach that? How would we implement that? Errgroup with cancellation. So we initialized Errgroup like that, Errgroup with context. We give it some context. If no context from before, then we just take the background. And then it's quite similar to the example that I presented before. Just we will have another Go routine, which will be the task generator. So we call ggo. This will be our task generator, some method that's called generate tasks. And I initialized here a channel on which the sender would be sending all the tasks to the tasks processor workers. So generate task will receive two parameters, the context and the tasks channel. And the workers, they also would have their method, task processor worker, and it will receive as well context task channel. And I just send also the number of the worker. And we wait for everything to complete with gwait. If any of those Go routines, either the generator or the workers, return an error, then gin.wait will return with an error. So now the question is, how do we know to stop? When we had some error, how do we know to stop? So inside, this is why we pass the context. All the Go routines that are working are being passed the context. And then let's see, both in the sender and in the receiver. What do we do in the sender? In the sender, we have some loop. For example, we're looping over updates and we generate task for update. It's just a pseudocode. Okay. And during the task generation, we can have an error. So if we'll have an error, we just stop the process and return the error. Okay. And anyway, we make sure to close the task channel. We make sure this closing the channel, it sends signal to the receiver that they can stop processing tasks. Okay, because it finished, task processing has finished from the sender side. The sender will not send any tasks anymore on the channel. This is just common Go practice. Okay, to send, sender sends on the channel, and after he completes to send on the channel, he closes this channel from his side. It should be closed only from the sender side. So, but sender also listens for errors that can come from the workers. So how does it know? There is this select, and the select has two clauses. Clause to either to send the task to the channel, or receive context done. Context done will be called this context done. This is actually a channel, done channel, that is closed when any of the workers returns an error. And Go works that if a channel is closed, then we can receive immediately from done. So this select statement, it will return when one of the case statement will be ready arbitrarily. We're not promised any order. So either some worker receives from the tasks channel, we try to send and someone received from it, or the done channel was closed. So if here some worker will return an error, the Errgroup will close the done channel, and we will exit on the context done, and we just break from the loop and return. We break, in case of error, we break from the loop, return, then because of the defer, the channel will be closed, the task channel will be closed. Now, how it looks from the receiver side. In receiver side, we have a loop that runs on the tasks channel. This loop will be ended automatically when the channel is closed. So we keep trying to receive tasks. And then how do we watch for cancellation? The same, we have a select, and this select has two clauses, either done, that means that some error happened, and then we exit, or if no error happened, we just processing the task that we received. And that's how we can satisfy all the requirements of the pipeline example. So that was my example. Very, very common scenario, actually, and one that is kind of tricky to implement. And Errgroup makes it quite elegant, in my opinion. If you notice any problems or mistakes, feel free to reach out now if you have any questions.
Great. Hey, Dima, thank you so much. That was really, really great. Any questions? Any questions? Anybody can take yourself off mute and ask, or you can drop it in the chat and I'll read it. Either one of the two would be great. No, going once, going twice.
Actually, I do have a question here. This is Mihai. Can you talk a bit about the performance of this? Like in some cases, I see that people are not too happy with channels, and I'm not sure if you've seen any performance issues with it, or like, do you see cases where you have to like just drop to like using atomics? Or?
Sync atomics. Yeah. Well, it really depends. Like what scale of magnitude we're talking about, right? So generally speaking, when we're using channels, the functions themselves, like those methods that are generating and processing tasks, they just many order of magnitudes more. The processing takes many magnitudes of orders more than the synchronization that happens with the channels. So it doesn't really matter. Like if processing task takes like 100 of magnitudes more time than the synchronization mechanism, I wouldn't try to optimize on that. But if the processing is something that is super fast, then, and it is comparable in orders of magnitude with the synchronization, then and it is very important, like real time, I don't know, then we can start thinking about. I actually never worked like on problem that where the processing is on the same scale as the synchronization. Does it make sense, the answer?
Yeah, thank you so much. That's what I was kind of thinking myself. Thanks a lot.
Dima, there was a question. How do you capture error for pipeline design pattern using Errgroup?
How do I capture error for pipeline design? What do you mean?
Can you clarify that some more, Renee?
How is the error captured?
The weight returns the first
The
error.
weight returns for the first error return. That's right. We can look also in the internal implementation. It's really, really simple, the internal implementation. I encourage you all just to look at it. We can just go, I'm sorry for jumping here. Where is our Errgroup? Here. So actually what happens behind the scenes is that there is this error once mechanism, and we save the first error that we received. So this method, when some error is returned, we just save it internally like that. And it will happen only once for the first error. That's actually a very short and sweet implementation.
Yeah, we'll
Oh,
it'll also exit immediately. So
Yes.
all the other Go routines, this is actually, you don't have to do the context cancellation pattern in order for this to occur. Even without invoking the Errgroup with context, the very first error will close the group.
No, the methods are running. They should know when to stop. All the Go routines are not finished. They should finish by themselves. So they should actively monitor this context, the context done, to know where to stop, because otherwise nothing terminates them externally. They should know by themselves that they need to stop working. Of course, we could just let them work until and be finished. At least if the channel would be closed, we could just do it in this example only from the sender. When the sender knows that he is complete, then he would close the channel. But what could happen is that he already completed, sent all the messages. For example, if we would have channel that has some buffer, we could have a situation when the sender is already completed, but the receivers are still in processing. And maybe those are things that are taking time, and there's something in the buffer, and we want them all to end simultaneously. So I think like the most robust solution that makes no assumption is both in the sender and in the receiver to watch for this channel, for this done.
Great, thank you very much. We may have time for one more question. Does anyone have one more question? Okay. Dima, thank you again so much. Really pleased that you stayed up very late for us, and it was a really enjoyable and educational talk for all of us. So thank you again, and looking forward to seeing you again soon.
You're welcome.
Thank you. Without any, I'm going to go ahead and drop all those links that I mentioned to you. First, I'll drop the JFrog link, followed by all the birthday activities for the week. It's a big, long text. So feel free to check it out, explore, etc. And at this point, I'm going to also welcome Amit, who's going to be sharing with us. And he'll give you some more details about his background, but very excited about the topic this evening. And Amit Mishra, Director of Engineering from Fox, is going to share with us about some very exciting, a very exciting talk that he actually gave over at Go West earlier, not too long ago. Actually, that was only a couple of weeks ago, wasn't it, Amit?
Yeah, I think 2 weeks before. Yeah.
Wow.
Yeah.
So this is a good fresh talk. I'm assuming this hasn't been done at too many meetups since then. So we're really pleased to have you, Amit. Thank you for coming.
Thank you so much for the opportunity, and wish you all happy birthday to GoLang, the whole GoLang community, and nice meeting to you guys. Let me share my screen real quick. Are you able to see my screen? Cool. Yeah. As already mentioned that, yeah, I'm Amit Mishra. Today I'm going to deliver the talk on building a scalable API platform using GoLang. Well, what is the motivation behind this talk? Basically, like as a director of engineering at Fox, me and my team is responsible for building and kind of taking care of an API platform which helps to serve live and on-demand contents to millions of concurrent users. And as you understand, serving live content has its own challenges because of dynamic nature of the users, their locations, and the content itself. Our API platform helps to serve the contents for the events like Super Bowl, NFL, WWE, PBC, or lots of Fox Entertainment related shows. As part of this particular talk, I'm not going to cover the whole API platform. I'm just going to cover a very interesting portion of our API platform, which is the playback portion of it. So yeah, let's dive into real quick the agenda for this talk. First of all, I'm going to go over and explain what is playback API platform for us is, and then we will understand the challenges, and we'll see why did we think that we had to rebuild it, and why did we choose Go, to rebuild it. Also, how exactly we rebuilt it, and then we will go over some couple of results. Right. Let's look into what is API playback API platform. So for us at Fox, playback API platform is basically a group of backend services, which of course helps to serve the live and VOD contents to various Fox products. But at the same time, these backend services helps to generate actual playback URL for the users, which basically serve the actual video for any user. So that's a very critical portion of these services. Apart from that, other critical activities which these services performs are like collecting analytics from the clients, and based on that, taking actions. Apart from that, there are like other things which these APIs serve are like couple of metadata information, normal UI decoration, like title, description, and all those kind of things. So once you play any video, as part of the video, the live video experience, the most critical portion is the serving the ad experience also, and that becomes very important for us because it is directly related to our revenue. So that is one of the thing or critical activity these services performs. Let's go over very high level architecture for this particular existing legacy system. So our legacy system used to be a kind of monolithic monolithic services written based on the Node.js. It had a couple of internal modules, and each internal module had very complicated business logic, because you can imagine when you are serving any live content to particular user, it depends on lots of various factors. The factors like, okay, if user is subscribed or user is unsubscribed, versus user is which location user is based on, and similarly, the content itself is available for that particular reason or not, right? So these are like a couple of examples where these things becomes more complicated, and because of that, these decisions becomes more difficult to make, especially at the backend side. And apart from that, as I said, like it didn't have any one internal module. It had like 20 to 30 internal module, and these internal module were like talking to one data store, something like Elasticsearch or DynamoDB. But at the same time, we also had dependency on the external services, where we are basically depending on streaming URL kind of systems or ad kind of systems, So what were the challenges with this particular, architecture? So as you could see, this whole thing was very tightly coupled in our mind, right? And because of this nature, it was very hard for us to scale this whole system, especially after since last 1 year or so. We had a very different traffic pattern. The digital streaming viewership is increasing, and the traffic pattern in some of the cases are very unpredictable. And in order to basically fulfill those traffic pattern, we need to have we need to have a way to auto scale these things in such a manner so that we can serve all these users. Other challenges are like external dependent services without any fail forward strategy. So as you could see in this architecture, all these external services were directly connected, right? So if something fails from the external services point of view, we had to fail the whole user experience, which was not a pretty good experience from the user point of view. So we were totally depending on the mercy of the external services in this case, like, and we did not have any control that how do we control if something is happening from their failure point of view. The other challenges were like, as I said, like we had dependency on the single backend data store. And the data stores like Elasticsearch and all are very difficult to scale on demand. You require lots of preparation before we could do that. So that is something we wanted to basically solve as a problem for us. There were other challenges were like we did not have any caching in most of those scenarios. And initially this was done because of the dynamic nature of the live content itself, because contents are live, users are also coming up from the different handle so caching those kind of contents are very hard in advance. So that is something we wanted to explore, that and how exactly we can handle these kind of problems. Other things was like hard to release any new feature, since this whole backend service platform was being used across different Fox products. Releasing anything came up with very high amount of the risk, because even a single change might have any side effect and it might break some different experience onto some different product. So we wanted to have some way to start releasing our feature faster. The biggest challenge we had was that once, even if we wanted to build a new API platform, how do we build these API platform and how do we migrate to this new API platform without any downtime? Because as I said, like all these are live events. We have every week, we have a couple of events scheduled, like it starts from Thursday, Friday, Saturday, and Sunday. And right now there is NFL events going on, as you guys are aware. And so because of that nature, we still needed to have the ability to migrate to the new API platform without disturbing our current operational mode. So that was a pretty interesting problem to handle when we were building this API platform. Other kind of goal we wanted to have was like we wanted to have our API platform by default supporting to at least millions of concurrent users without any live ops or any on-call kind of support, because as I said, like in last couple of years, digital viewership is increasing significantly. So because of the increased amount of the traffic on the normal day, we cannot expect all the folks sitting and supporting these kind of things. So that is what we wanted to have. Our default platform should have the capability to support at least millions of concurrent users. Similarly, for the Super Bowl kind of event, we wanted to have the ability to have at least 10 millions of concurrent users, so that we can fulfill the requirement from the user point of view. Other goals were which were pretty important for us were like handling the scenarios like thundering herd. And a thundering herd kind of scenario can happen in some of the normal cases like ad breaks, or some of the problems where app crash happens. In case of app crash, imagine you have millions of concurrent users watching the stream or watching a particular event, and suddenly if your app crashes, then as a user you are going to retry a couple of times to get into the streams, right? And when that happens, all these users will send the unexpected traffic to your backend system. And if this happens, in some of the cases, this kind of traffic becomes very unmanageable. And so we wanted to have some innovative ways to handle this kind of traffic pattern. And the same applies for the ad breaks. When there is an event going on and we are in mid of the event, and suddenly if there is a ad marker and there is an ad break happening, then all the users and all the platforms are going to hit our backend system, which serves the ad at the same time, right? So in that case, and these ads are so dynamic in nature because of the users' locations and user subscription profiles. caching those kind of details is very hard in advance. So those are very dynamic, right? So we have to serve those, and that also kind of creates a unique problem of thundering hard. And other goals we wanted to handle was like, how do we actually support the game extensions for any kind of live event? Because whenever there is any event going on, there are higher chances that that event might be, extended. So the way in digital streaming world, we basically serve these events like we allocate the slots in advance. Okay, this we just predict like, okay, this particular event is going to happen for these many hours. Okay, and after that we have this particular program is scheduled. So all these things are decided in advance and kind of like served to the users. But if the live event is extended, then that whole scheduling kind of like disturbed, and we have to reconfigure those things. And if that happens, then the whole backend system is kind of reset itself, and so that it can serve or continue serving those live events. But at the same time, because of that, it might also create thundering hard kind of problem, because your whole system is gonna reset even if it was cached, right? Other future goal was like, as I mentioned, that we wanted to have some ability to have at least a graceful degradation. As I said, like if any external services are failing or internal services are failing, then we wanted to have some ability to monitor those and take some corrective actions, and then at least implement some kind of fail forward scenario, so that user experience is not interrupted. And in line to that one, we wanted to have the ability to support robust monitoring and end-to-end logging or observability system, so that we can see what's going on with our system. And of course, we wanted to have our platform resilient for common failures like infrastructure outage or third-party system issues and all those kind of things. But how exactly we handle those problems? One of the things I want to mention, that while looking into those challenges, we basically made a conscious choice of choosing Go because of its simple nature. Most of our developers were coming from the Java or the Node.js background, and none of us had kind of like experience. It was like 7 years before. But when we started doing a small POC based on the GoLang, we got lots of confidence, and we wrote like our first service like for account system login service, and we deployed it. And once we deployed that to in production, we never had to look back, and our performance increased for that system significantly. And that was the experience we were carrying while thinking about rebuilding even playback platform. Yeah, so let's look into how exactly we tackled all these challenges. So as I said, like in the beginning, our legacy system was very tightly coupled. It was kind of a monolithic in its nature. So one of the things we decided, okay, let's start thinking about breaking this whole system as true microservices, right? And the criteria which we decided were like very obvious. Like, okay, first think, okay, how many external services we were depending on, right? Secondly, take how many internal services we had, which we cannot migrate to GoLang, but can we do something around those services so that we can still implement fail forward kind of scenarios, right? And the third and the most important aspect was like, how do we handle the dependency on the data stores like Elasticsearch and DynamoDB? So we basically broke those kind of pieces into its own microservices, and so that they are just having dependency on the Elasticsearch and DynamoDB instead of like having external and internal legacy services. So one of the thing as part of the true microservices when we thought about was like, okay, that how exactly we migrate, even if we wanted to build a new system, how exactly we migrate. So that was the strategy I wanted to present here. So here is the like one of the example state here. Like initially, like this is how the very simplistic view looks like. From the client point of view, we have some API gateway endpoint, and there will be some legacy backend playback service to initially start with. And what we started doing in our system first was like we started introducing GoLang based proxy on top of all these legacy services. So that this particular pattern is a pretty strong pattern. Like it provided us the lots of flexibility. It opened the door for lots of opportunity in background. In this case, we did not make any changes. The kind of job proxy was doing, it was just taking the same request, it was taking the same response to the client, it was giving back the same response to the clients. But at the same time, it gave us lots of flexibility, which I'm going to explain you in a couple of next slides. And once we had the proxy, what we started doing, we started making our services in new services in parallel to legacy services, and we started swapping those components one by one into its own microservices. And when we were doing that, we were able to do the comparative testing also, because we had the whole production data and the live data coming in as part of logs, so that we could basically grab those things and then we can simulate the test and see what's the behavior with the new playback services. And once we had that, we kind of like implemented a feature flagging kind of concept there, where we deployed our services to production. It is live, but we still kind of like saved, or like we still put this to behind a feature flag, so that if there is any issue going on or something happened, we can turn on and turn off based on what kind of behavior we are seeing. And once we had that, confidence, okay, everything is working fine, then we were able to remove on the proxy, we were able to remove feature flag, and we had our new playback service in production, and without any downtime. So that was like one of the innovative ways we came up with in order to deploy our services. And this is a very established pattern at Fox. We are still in process of migrating our whole platform to new GoLang based platform, and this is the pattern we are basically following right now. Another pattern I would like to talk about is like circuit breaker pattern. As I was explaining that as part of the first proxy thing, it gave us lots of flexibility, and the proxy gave us lots of flexibility because of the circuit breaker pattern. So whenever we implemented a GoLang based proxy, we also implemented a circuit breaker pattern with those proxies. And as soon as we implemented circuit breaker pattern, basically it gave us the flexibility to fail forward. We could basically we could track all the responses from the external services or the older services, and track the error codes and fail based on that, and probably provide the fail forward response. So that is what we did. This is one of the circuit breaker config we have. So currently, like as part of the implementation, we use Hystrix Go package, and this is the config it looks like. Like as part of the circuit breaker pattern, we basically had couple of things in a configurable mode. Like if we want to enable the tracing basically gives us the full dump of the logs in case we want to debug something. We could also configure like error threshold, where we want to see, okay, circuit should open after certain percentage of the errors. So by default, we kind of like do like 20 to 25%. So if 25% of requests are failing, our circuits will be open, and if that happens, then we all automatically go to the fail forward kind of scenario. As I said, like we also needed to have the capability to understand if it is external services or internal services. So we had that flag and configurable. Similarly, at the circuit breaker pattern level itself, we kind of like implemented max concurrent request count, so that we are not sending unexpected amount of the traffic. We were able to control the traffic at our caller services level itself, and the same like request volume threshold also complement to the same kind of feature. And then there are other features like timeout, like in case external services are very slow to respond, then we needed some way to, time out those services, and then based on the timeout, capture those errors, and then basically take the corrective action for these services. As I said, because of the simple nature of the GoLang, we were able to implement most of our circuit breaker code in such a manner that as a developer, once we had that implemented, we did not have to do lots of job when we were calling those things into another services as part of the color services. As you can see, like whenever we wanted to integrate integrate two services, this is what we had to do. We literally had to implement our circuit breaker struct, and then pass couple of params, and capture the response and send it back. That's it. So as a dev, it became very easy whenever we wanted to integrate with any services. And as part of circuit breaker configuration, as I said, like we also had the options to basically configure like things like retry, like in case there is a failure happened, do we want to retry that service or not? Like like for example in timeout, let's retry or something like that, right? So it gave us lots of flexibility from the implementation and the development point of view, but at the same time it also opened the door for us to monitor our system in a very flexible manner. This is one of the circuit breaker based monitoring. Now you can see like we had bunch of like as part of one service, we had a couple of other services which are being called or dependent services, and this is how we were tracking. Okay, these are the hysterics durations. This much time it took for us to basically call those services. We were also able to track like hysterics errors or hysterics timeouts, and then status of our circuit itself, that if it is open or closed, and based on that our ops team can take the corrective action. Once we had this thing implemented, we started thinking about caching, and as I said, like implementing caching in live environment is kind of very tricky, right? But we still made a conscious choice of start caching a couple of things just for a few seconds, and not for like longer period, but that few seconds of caching itself gave us so much scalability power to our our services. And one of like couple of features we implemented using GoLang based caching was leaky bucket kind of caching or a stale cache, right? Leaky bucket basically helped our cache to keep warm all the time, without any manual effort or without running any background job for warming up the cache. A stale cache basically helped us to serve the content in case of any external services failure. So based on the previous response, we could cache those things from the external services. Of course, we cannot cache everything, but we were very selective about okay, what can be cached and what cannot be cached. Based on that, we could cache some of the content which is cached for longer period of time, and we could serve those things in case of any major failures. This is one of the example we had implemented. So as part of the caching, it's like a normal pattern. Normally people try to implement. Like we get lots of bunch of video IDs from the request point of view. We try to go and get all the things in batches from the cache, and then if something is missing, then we go and get individual IDs and data from the cache, and again cache those back into in background, basically asynchronously. So this is just the same thing happening here. One of the very interesting package we found as part of the GoLang library was the single flight. It basically helped us to implement or take care of the thundering heart kind of problem. As you can see, like or understand, like single flight is basically just a pattern which basically helps you to suppress all the duplicate requests. So in case of like I was talking about the ad break kind of example, in case of all the clients who are sending similar kind of ad request, we were able to identify all those duplicate requests, and instead of sending all those duplicate requests to origin, through the single flight implementation, we sent only one request to origin, got the data, we cached the data, and then served the rest of the request from the cache itself. So that kind of like, provided us so much flexibility when it comes to have had the dependency like Elasticsearch or single data store itself, because now we were able to serve most of the content from the caching itself instead of sending all the contents or all the requests to data store itself. Other pattern which were very useful was like API gateway throttling. So as I was explaining the app crash kind of scenario, those kind of scenario and the kind of traffic you start getting is very unpredictable, right? So for those kind of things, we made a conscious choice of disabling the auto retry first of all, and then let the client initiate or let the client retry for the playback. And if we were getting lots of requests, we basically kind of like throttle those requests, because our API has infinite level of scaling capabilities right now. But at the same time, the truth is like all other external services wouldn't have those kind of capabilities. So in order to do so, we had to protect ourselves in some of the cases. This does not happen in all the time, but for very high traffic event, we had to have this kind of things implemented. As I said, we kind of like, disabled the auto retry for some of the major events and dependent on the client related retry. And not only that, as I was explaining, that we have a couple of more, like we have the events like Super Bowl, and we have the events like, NFL, WWE, which are like normal, like every weekend kind of scenarios, right? So for those kind of things, we wanted to have some capability. Okay, how do we prepare ourselves from partial versus major failures, right? So this is where we came up with like, okay, DEFCON mode kind of system, where DEFCON 5 was like a normal behavior, where things are running absolutely fine. But if in case anything is failing, then we had the feature flags implemented, where we can just turn it on, and there will be some degradation on the features, but your user experience from the streaming point of view will be still fine, and as a user you can still watch the event without any problem. And in those cases, whenever we turn on those flags and whenever we implemented this kind of DEFCON mode, these did not require any kind of restart from the backend services point of view. It was very seamless from the client point of view. You wouldn't even know that you're running on a degraded feature system. So that was pretty cool from the failures point of view when it came to handle those. What were the results after we implemented all of these? Like, as I said, we have an infinitely scalable playback platform today, and we have very, very fast services. Like as you can see, this is just one example, but there are like tons of examples. We have that where we had the the Node.js based services performance kind of like not that great. But at the same time, as soon as we went to GoLang, we got like lots of improvement, and because of this, what happened, like our number of ECS container count for the services were reduced to 50%. The way GoLang manages the resources, it helps us to save lots of cost. And our overall spending on the AWS itself became, reduced by like 30 to 40%. We are already seeing those results, and this is one of the reasons like we are now like going towards GoLang more and more. As I said, like the implementing and the releasing feature was faster, was very critical to us. And after moving to the GoLang based microservices approach, we are able to release our features 100 times faster. We have every day we have at least live deployment going on without breaking anything. and it does not require any kind of interruption or any kind of like setup of war room. People can just go to Slack, they can hit the deployment when as soon as their feature is basically tested and verified and approved, they can go ahead and deploy it. And it does not affect anything in that case. So that's a pretty big flexibility we wanted to have, and now we have that one. Similarly, as I said, like we have better tooling to monitor APIs end to end, and currently, like Super Bowl 2020, we served in 4K, and lots of even current NFL event we are serving on 4K. And because of the this whole refactoring onto GoLang based services, it provided us those capabilities to add these kind of features, very fast and deploy and test those out. Yeah, and at the end, as I said, like we have a very high successful team. This is a small moment from Super Bowl 2020. Yeah, and yeah, if you guys or anyone is interested joining our team, please feel free to reach out to me. We are actively hiring for various roles. So please, yeah, reach out to me. Also, if you guys would love to read about more cool stuff, that what are we doing at Fox, we have a Medium platform set up there, Fox Stack. You will find lots of good technical implementation using GoLang into those. So feel free to go over those. And if you have any question, please feel free to reach out to me. Thank you.
Thank you so much, Amit. That was awesome. You can unmute. I accidentally muted you, and I tried to unmute me. But I know we'd love to have some questions. I know one person asked a question in the chat. Did you write an API gateway, or did you use an open source or third-party component for that?
We use AWS API gateway.
Oh, okay, great.
Yeah.
Awesome. Let's see. Bill has a question as well. Any idea how much of the performance improvement was due to the node or to Go change versus other improvements like caching?
Yeah. So node to GoLang, we saw a lot big performance boost. As I said, like we had a normal Node.js service running. And as soon as we added just the GoLang based proxy services, that itself gave us so much performance boost without doing anything. We were also puzzled that how did it happen, but then we figured out the way GoLang was managing the resources internally, CPU utilization and memory utilization was pretty awesome. And that is where we saved lots of things. So definitely, like compared to Node, we started seeing those performance boost. And on top of that, when we started adding other patterns, it basically gave us more flexibility and boost.
Great. Any other questions? Anyone want to take themselves off mute and ask Amit any questions? I thought it was a really interesting, definitely DEF CON 0 in my house if the Super Bowl is on. I'll tell you that, and there's a failure. That would be horrendous. And so it's really interesting to see how things are going on behind the scenes. Especially with things that are very, very much in our everyday lives, especially with COVID and all the streaming that we did. It's great to see the technological advances and the architecture that you and your team put together at obviously a major live streaming outfit for sure. Why did you choose ECS over the other container orchestration options? Yeah,
ECS Forget because it's self-managed by AWS, one of the things, and it was so basically we are our whole platform is on AWS. We are not multi-cloud system. Everything is on AWS. So that was like kind of like obvious choice for us, and so we used Docker to basically build the images and just go through the ECR and then deploy to ECS. So it basically fits very well with the AWS ecosystem. That was one of the reasons, we went with that one. It doesn't, we don't require to manage lots of things on our own or manual manner when it comes to ECS.
Okay, great. Any other questions? Anybody want to come off mute and ask something for Amit?
Hey, Amit, thank you for the talk. Mihai here. I'm really curious, since you're saying that you're so closely tied into AWS, I assume all your stack is running there. What does it look like for you to test things? Like, how do you do integration tests? Do you spin up infrastructure in AWS and wait for that to run the tests, or how do you do that? I would imagine that's kind of slow. That's why I'm asking.
Yeah, so we have our own load kind of environment set up based on AWS, but we use K6 a load, to write our script and all. So we have the whole system, and in order to run our load test, we basically plan those out in advance and test it based on that one. Because based on the nature of the event, we kind of like predict what kind of traffic we might be expecting. So we basically add more padding on like 10x or 20x on top of it, and then that's how we kind of like spin up and test it.
Well, thank you. And can you talk a bit about how much time it takes for you to spin up that environment? Like, is that not kind of annoying for people to wait for all that infrastructure to spin up in AWS?
Honestly, it's not a big headache, because for the load thing, we have a pretty much established process. We kind of like, schedule those in advance, so it takes like, maybe half an hour to 1 hour, but those things are already set up in advance by our ops teams, so that all the engineers doesn't have to sit down and wait to come up with these environments. Also, these environments are pretty temporary in nature. As soon as your load tests are done, those are destroyed, so that we can save some cost. We are not just running by default on those kind of modes, right?
Oh, okay, thanks for that. Like 1 hour sounds doable. I've been in the past in an organization where it took like a couple of hours and it was like a nightmare.
No, I don't think I think when we were setting up initially, like, these kind of things, we had those challenges, but currently the process is pretty smooth. It doesn't take like, more than, I would say, a couple of hours, like, 1 hour, 2 hours. But I have never noticed more than that. If it will be, then yeah, that's a problem. I agree with you.
And you deploy with Terraform or CloudFormation?
We use Terraform. So as part of our whole microservices skeleton, which we wrote in GoLang, we have the Terraform modules implemented. So as a dev, when you're writing a services, you can basically write your own infrastructure. Let's say you want to spin up your own Dynamo, or you want to configure SNS or SQS. You have full control as a dev to build those things as part of your services itself.
Cool, that sounds great. Thank you.
Welcome.
Thank you, Amit. We have another question here from Bill. Curious if you know how much your productivity improved moving from Node to Go. Also, by allowing much easier use of better pattern by circuit breaker, etc. Does that make sense?
Yeah, totally makes sense. So yeah, that's one of the most strongest point GoLang provided us, like the speed of development. Like initially, writing one microservices used to take us at least 2 sprints or 2 weeks. Today, like if it is a simple microservices, we can spin up a production ready microservice within a couple of hours. And I would give an example of Super Bowl 2020. Whenever we were writing those microservices, we were literally like finding out all the bottlenecks during our testing on fly, and we were writing those proxy services within 2 hours of time, and we were deploying those in production. That was the kind of speed we were able to achieve. So normal, normal service itself or product like development time has decreased at least like 80% to 90% after moving to GoLang based services. And what was the other question on that one? Sorry, oh yeah, the other patterns, I would say we are exploring in this one, apart from the caching, is like more innovative ways of caching the things like Russian doll kind of caching or those kind of pattern we are exploring right now. Also, we are also exploring the options of implementing the multi-region kind of capability for our services, so that we stop depending on DEFCON mode kind of things. So that's one of the things we are exploring for sure. Also, as I said, we are heavily depending on Elasticsearch, and a couple of months before, AWS launched the features for the replicating the Elasticsearch data. So now we are going to basically implement those kind of features also, where we can start replicating our data on live, so that it kind of give us more scaling power.
Okay, great. There's a question regarding the monitoring tools. Can you please describe what monitoring tools and products you use? Did you embed them in your code?
Yeah, so the monitoring tool we use Grafana and StatsD. So StatsD, as part of our GoLang microskeleton itself, we have implemented the StatsD package. So whenever we want to send any metrics, we just basically, as a dev, you just have to call those dependencies, pass what kind of metrics you want to track, and send it across. And the same applies for the logging also. So from the stack point of view, we use Grafana for the visual point of view, but internally it's basically InfluxDB based system and StatsD and Telegraph.
Great. What is the best way to learn more about the roles you're hiring for?
Yeah, definitely. Let me share the link here as part of the chat, so that, yeah.
That's great.
Yeah, here. Personally, me and my team is hiring for software engineer, senior software engineer, and software manager and senior software managers roles. And we are actively hiring. We need so many people. So please feel free to reach out to us. Would love to work with you guys.
Great. Awesome. Well, we really appreciate the talk tonight, Amit, and for Dima, who I know signed off a little earlier because of the time in Israel. But a couple things. I did drop the JFrog Raffle link one more time for the Switch Lite for anyone that is interested. I'd like to see about having a meetup in December. I hate to miss a month. It just seems like it's I don't know. We've been going so strong, but at the same time, it is the holidays, and having a meetup just for the sake of having a meetup is not necessarily great too. So we'll see if we can get some good content for the month of December and I would love for it to be somebody that's here tonight. So please let me know if that's something that you would like to do. And as far as we had 2 people ask for, I'm not going to spin the wheel because 2 people asked for a JetBrains license tonight, and they are our winners. That's Bill Bartlett, and also we had been asked by Vinaya. I will go ahead and send those out to you. Hopefully this evening, you'll get those. Go ahead and activate those as soon as possible, because based on your activations, JetBrains continues to send them to us. So love being able to give those away. And I'm trying to think if there's anything else this evening. I think we're good. Lots of thank yous in the chat. And anyone else have any announcements or anything to share before we head out?
Hey, Ari, have you ever had a talk on Bentos? So Bentos.dev, the streaming processor.
I don't think so. Is that something you'd like to share on?
I could. I mean, I'm going to talk about it at the GoLang Northeastern meetup, but if you're okay to have a duplicate of that, then I could try to do that.
I don't think, to my knowledge, there's not a lot of crossover in that. So yeah, I would love to. If you want to go ahead and forward me an abstract and everything, are you on the Slack channel for Go?
Yeah.
Me too. I'm always, you'll always see me on there. So go ahead and Slack that over, and let's talk about that for next month. That would be awesome.
Yeah, probably around December sometime.
Yeah, December 25th. What do you think? Is that a good day? I'm kidding. No,
I'm happy with that as long as we have some audience.
Absolutely. No, we'll figure out a good time, but that's great. Thank you so much for that. Yeah, you don't have to go through the call for papers process. That's out there in case, just in case, but you can always reach out to me directly, and
Sure.
we can chat about that. So.
I mean, this might be of interest to Amit here. I'm not sure if he looked at it, but if you're curious about data streaming and like using a stream processor, bentos.dev is something that might interest you.
Very cool.
Yeah, definitely. Would love to hear about it.
I'll put the link in the chat.
Awesome. That's great. Well, I really appreciate it. Anybody else have anything else tonight? Awesome. Well, thanks again, Amit. And everyone have a wonderful Thanksgiving holiday, and we'll see you next month. Have a good night.
Thank you, everyone. Good night.
Bye.
Bye.